from the first time you called me late. Loved you for your wits and your wicked games. Yeah. Always on my mind, always in my brain. Yeah. With you, the summer came and went in a day, and I've been craving you since the first time that I sat by your side. And I've been on my knees thinking time is gonna fix me inside. No, nothing's gonna make me forget, and I don't think I want to forget anyway. Yeah. No, nothing's gonna make me forget. Yeah, I don't think I want to forget anyway. Yeah.
Oh, okay. Are we ready for this? Showing off new toys? I don't think so. Hello and welcome back to the IQ Workshop. Tonight we're starting a really exciting project. We're starting a journey on electronics fabrication, and we're going to be making a machine that should hopefully make that process a little bit easier. Sound a little muffled. Hey, C Waffles. Hey, Row Rally Race. Hey, Dimitri. Welcome in. Welcome. So, the journey that we're going on is we're going to be making a pick and place machine. Not any old pick and place machine, I'll have you know. It is going to be a open source, a LuminPnP machine from Opulo. Yeah, we're gonna be building it from scratch. we're going to test open source hardware. It's a thing, and we're going to have some fun trying to put this machine together. Now, why am I building this machine? Well, I'm building this machine because I've got a couple of side projects whereby I may need to do some batch processing of circuit boards. Essentially, what this pick and place machine is going to do for me is automate the process of picking up small components and placing them on a PCB. And it's going to be able to do it faster than I can. It won't want to take breaks. And when I get this all set up and configured, I can pretty much load up a board, get all the components in, and hopefully press a button and it produces all of these circuit boards ready for me. I will still need to have to solder these components down. And that's going to be dealt with through a process of pasting the board. Essentially what you get is a stencil. When you order your manufactured circuit boards, you order a stencil, and these have like the pads cut out of a piece of metal, and you can get this paste-like substance, solder paste, and you can screen print it over the top after aligning the stencil and the circuit board. Lifting that up, you'll get a perfect amount of solder on each of the pads. So when the pick and place machine puts these components down, it sticks in this paste, and then you put this board or panel of boards into an oven, and you bake it for a set period of time along a temperature curve profile for the solder paste, and it makes all of the connections. And this is how large volume manufacturing is done for circuit boards, except the machines you do for like the top end stuff, they're really rapid. And yeah, so the Opulo LuminPnP is intended for a small to mid-scale manufacturing outfit, and I would like to think that I'm going to be entering in on the small side, scaling to the medium, but that's going to be another journey in of itself. So we're going to play with putting the LuminPnP together. So can I just get some feedback on my audio? I see in chat that a couple of people have said that the audio is muffled. Am I in sync? I haven't checked audio sync, so I could be looking like a really bad dubbed movie right about now. Raid Shadow Legends sponsor money. Okay, so let's quickly have a look at the LuminPnP. So you can actually buy the LuminPnP from Opulo, and it is a produced piece of kit. You can purchase it for $1,995. And that's pretty much the machine partly assembled. It's a semi-kit form where the main gantry elements are put together and you have to assemble them. You have to install what are called the stages. This is these sections here. You load up a bunch of electrically driven mechanical part feeders. And essentially you get your components on a reel, a tape, and essentially this automated device essentially advances the tape every time it wants to go and pick up a component. So no worries. Thanks to you, Waffles. High-end stuff, super cool, stupidly expensive. Decent one costs like 15k, right? So the Opulo is a company that has been formed to produce the LuminPnP and accessories. It is an open source project, meaning that all of the design files, all of the CAD, all of the bits and pieces you need to put this together yourself are actually freely available. And if you have the skills and know-how, you can put one of these machines together. And we're just going to quickly take a look at the project. Before we get into the hardware, I've been itching to put this together. This has been on my bench waiting to be put together since Thursday, Friday of last week. And I've waited for this stream to put this together. And I am super, super excited to see how this comes out. Now, just to be clear, we're not going to get a working machine out at the end of this stream, but we do have some goals for the stream. I would like to have the base frame completely assembled. It will not have the linear moving parts. Those are on order. We're waiting for those to arrive. And yeah, so we're going to take this as far as we possibly can without the linear bearings. And then when they arrive, we'll look to get another live stream together where we'll advance the project again. So coming back to the origins of this project. So way back in 2015, I started fooling around with 3D printing, and I learnt by building my first 3D printer from scratch. I sourced the components from various different suppliers. It was a little bit of linear rods from there and bearings from there, and so there was about, I don't know, 7 or 8 different manufacturers that I purchased from, like individual components, and I put together a raw stock 3D printer because at the time I thought that was a good way to go. It was definitely a project, and the resulting 3D printer was my gateway into digital fabrication and ignited my passion for making machines. And since then I've taken in laser cutters that have been broken, and I've been able to restore them back to a working condition. Recently done a CNC machine, brought that back to a working condition, all because of this first 3D printer that taught me so much. That 3D printer had a name, and he was called Frank. Frank is being reborn right now in a LuminPnP machine because we are recycling Frank's components to make the LuminPnP. So Frank's gonna live again. Frank, the unknown gateway drug, right? Yeah, print a laser machine thingy. That would be next level, right? So let's get back to taking a look at the project. So we've got the LuminPnP here, right? And the documentation of this, I mean, for your money, right? $2,000 US is good, because what you get is a pick and place machine that once you put it together, it's fully operational. It comes with a toolkit. It comes, let's just quickly have a look at this machine in action, right? Here we go. So this is what the LuminPnP does. I'm just going to mute this so I don't hear it. So this is Stephen Hawes. He's the founder of Opulo, and he's the guy, the brains behind bringing the LuminPnP together. And it uses OpenPnP software, which is a multi-platform pick and place software. And essentially, let me see, the machine picks up the components from the tape. It uses an optical system to look and orientate the component before then taking it over to the board and optically placing it on its pad alignments. So this is really cool, right? This to me, it just takes me back. This takes me back to the origins of me in getting into 3D fabrication, right? And this is like super cool. Right, Row Rally Race. So Stephen Hawes, he's there's a web. So there is links in the description of this video. If you're watching it on replay, or if you're here in the live, there are links in the description where you can see the Opulo website. There is the Opulo GitHub, which is essentially a library of all of the files. And we're going to take a quick look at that in a second. And It's got a ton, right? I so want to get into this, but we got to do the needful, right? We gotta take a look at the project, give credit where credit is due, and pay our dues, right? So the Opulo, I mean, the Opulo is very well documented. What I've seen, you know, this is just a brochure, making machines for mid-scale manufacturing, right? So this is that in-between sort of place. I'm not quite at the in-between just yet, but that, based on recent events, that could change very quickly. But, you know, the documentation of this project is incredible. Down to assembly instructions. The Opulo YouTube channel has all the assembly guides that you could ever need. But we're going to be building this from scratch, right? We're playing this game on hard mode. Here is the GitHub repository. Again, links in the description below. And as I say, this gives all of the files that you need to make your own LuminPnP. Yeah, Road Rally Race. They've formed a company called Opulo, and you know what we're looking at on this stream is the result of their labors. So I'm going to quickly go into the CAD, both for the electronics and also for the LuminPnP itself. We'll do the LuminPnP first. So what we've got here is a set of free CAD models for each and every component in this machine. So if we come into here, we can see all of the 3D printed frame parts. We can kind of select, say for example, we're going to do an assembly, and we will do an assembly using this this CAD model. You can select components like this bolt, and it tells you what size bolt that you need. CE Waffles, I'm aware of the audio drop, and that's a challenge of my broadcasting software. So. Well, I mean, we do have a bit of a challenge. As you'll see in a moment, my workbench isn't actually big enough to fit an Opulo on, so we're going to have to be creative. Why not? Okay, here we go. So, what we can do is we'll be stripping back the assemblies here so that we've got the visuals of everything that we're going to be working on tonight. So hopefully what you see on screen in a moment, once we've got this all dialed in, will be a representation of what we're going to be building. Okay, so there's that. Secondly, we've got the KiCad files. So KiCad is an electronics package. It allows you to draw schematics or maps for your components, how your components hook together. And this is incredibly detailed in terms of, you know, how all of this stuff hooks together. There is an absolute ton of information. It's incredible the level of documentation that this project has been able to achieve. I have seen corporate projects with less documentation than this project has. So hats off to the team of people that have put this together, both from an Opulo perspective, but also from the wider community. I believe this is a community designed board. There's I don't know the names of the people, I'll be brutally honest, but yeah, a guy who's got a PhD in circuit board design has designed this PCB, and this is the main circuit board that drives the entire machine. And what we've also got, not only have we got the schematics of that, but we've also got the board layout. So this is actually a 4-layer board, and if we jump into 3D view, we get to see what this circuit board looks like. This is absolutely crazy, right? So we'll be able to take these design files, send them off to an outsourced board manufacturing company, and we will get blank, unpopulated boards back, and we will be able to populate them. The documentation of this will also includes a BOM, or bill of materials. That essentially tells you each component name. So what the component is, whether it's a resistor, a capacitor, a connector. And then it has a series of values associated with it. So all of these chips, all of these resistors, they're all detailed in the bill of materials. So we can just go out, order all of those components, have them shipped, and then I can hand assemble a circuit board. So I think what I'm going to do with my circuit board, you know, it's got all of the Opulo sort of designs on it. I'm going to put an IQ Workshop logo on here because this is going to be my Opulo. But I'm just blown away by the level of detail that this has got. So one thing I just quickly want to shout out to. So some of you may have noticed that I've been switching my scenes and controlling my stream, and I'm doing that using my homebrew stream controller. And this is the sort of project that the Opulo can help with. For example, let me just grab a circuit board. So here is the brains of my stream controller. And it has a series of components that are laid out on it. Now the Opulo, I could load this board into the Opulo, and we can have this pre-populated. If it had a panel, we could have a bunch of these, like, I don't know, 3 or 4 wide by 3 or 4 deep, and the machine would populate, pick the components up and drop them into place on the circuit boards. Meaning that I can churn out prototypes and products to be sold on my website, at conventions, you know, and it's going to elevate my journey as a maker that next level. This is a workflow that I never anticipated. I always knew when getting into 3D printing that I was going to be doing things with laser cutters, and you know, future Steve was going to be doing stuff with CNC. I had no clue that I was going to get into circuit board manufacturing. So you never know where these projects end up taking you, and I'm hoping this is going to be a hell of a ride. I'm hoping this is going to take me to the next level. So let's get into this. Let's yap in. So here is the 3D model. We're going to turn off all of the bits and pieces of this 3D model that we do not want to see. And that will allow us to focus on putting these components together. So let me just turn off the strip feeders. So these strip feeders are these yellow things at the front here, I believe. That's the rear ones. Get rid of this feed rail. There we go. Ah, we actually do need the feed rail, because that is a string. That string's between there. Aha, so we're learning. So if anyone's got any questions in chat, feel free to ask away. He sounds very clever. So if anybody in chat wishes to support the project, there are links to my Ko-Fi, where if you feel so inclined, you can donate to the project. All funds that are collected will go to into purchasing components, and we'll look to incorporate, if you put in a message of your name in the Ko-Fi donation, we'll look to see whether or not we can customize this machine to have your names embedded into Frank, forever indelibly marked. So let's have a look at what we got in here. So the feeder rail. All right, we probably want to select this front feeder slot bracket, feeder slot set. We want to turn that off. This is going to take me a little. There we go. That's good. I'm not used to FreeCAD, to be honest with you, in terms of the... this is an assembly that we're looking at. So let's see if we can turn that off. Okay, so that's that. So we've got the slot sets turned off. We're going to turn off the Y gantry, I believe. X gantry. Yeah, let's get rid of the X gantry completely. There we go. Let's get rid of the drag chain. So we're just turning off all of the components that we're not going to be working on. Okay, so we've got the staging plates. Turn off the primary staging plate. We're getting close to where we want to be. Auxiliary staging plate. Now, auxiliary. The standard Opulo has 2 staging plates. I'm actually going to do a third. You can actually add a third. So since I'm making this, I may as well make the machine to have its maximum capacity. So that's where I'm going to go. Auxiliary staging plate. Else. We want to turn off the support foot. We're getting close now. Okay. So we want to turn off this front foot. I'm going to turn off this front foot. Oh, no, 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 no. We don't want to do that. Let's turn that back on. That we want to turn off. Front leg extension. Okay, that's better. Now the rears. So this is going to help us put this together. Now, we could attempt to try and follow the instructions on the Opulo YouTube channel, but because we are building this from scratch, it's not going to help us much because there's elements of that which are already assembled. We want to remove the linear rail. And the linear rail that side. And we're going to remove this component here, the gantry slider left. It's amazing, like I say, it's amazing that the level of detail that this model goes into. It's crazy. Absolutely crazy. We're going to go to the slider right, and we're going to go false on that. Bosh. Right. So, by the end of stream, I would like to have... Let's get this arranged so we can see it nicely. I would like to have this frame put together. Let's see what we got. Let's see what we got. So we've got a bunch of 3D printed parts. We exported them and 3D printed them in PETG. So let's take a look-ski at what we've got. We've got 2 front legs, one left, one right. We have got 2 rear legs, again, one left, one right. We've got our front pulley sections. Now, I was dumb and I forgot to purchase some angle brackets. But given that I've got a 3D printer, I decided to 3D print my own. Why not? And that means I can be in keeping with the black and yellow theme that we have got going on with the Opulo design. So in amongst all of this, we have a bunch of M5 hex bolts of various sizes. We have a bunch of nylon inserted nuts. We've got a bunch of regular M5 nuts. And we've also got some T-slots because we have a package here. Let's see if I can show you this. If I just flip the camera up. And let's go... let me just quickly... go into the overhead camera, and if I can just quickly rotate this a second. Funny thing is, I'm upside down now. When we go here, I'm upside down. So we've also got some extrusions. We got some 2020 extrusion. The extrusion is 600 millimeters. No. There we go. It's 600 millimeters all round, and there are 7 pieces that we're going to be using. So the first thing I'm going to do is I'm going to assemble the front legs. Let's do that. Well, that's not good. There we go. All right, so let's get a pair of these away, and we're going to deal with these one at a time. We don't need these at the moment. So again, if anyone in chat wants to ask any questions about the project in general, or even the reasons why we're doing this, feel free to ask away. We're going to look at this front section. So we're going to assemble these belt tensioners. So these belt tensioners, they require a GT2 pulley each. What else do we need? Let's have a look, shall we? If we select this bolt, it'll tell us what bolt we need. So here it is. It's behind me, is it? No, it's just above my head. Awesome. It's an M5 25 millimeter screw. Let's find my 25 millimeter screws. There we go. Here's a pack of 25 millimeter screws. What is the nut that we require? Let's have a look. I believe that is a nylon inserted. Yeah, it's a nylon inserted nut. So it's got a nylon lock nut integral to the unit. Okay, let's get and put that together, shall we? All right, so it should hopefully be as simple as taking one of these, sliding this into place, orientating it the right way, and then putting in a lock nut in the bottom. So I'm going to press the lock nut in place. Let's back out the screw, and we're going to place in our lock nut like so. And that's a pretty tight press fit in there. And I did some tuning on my 3D printer recently, and these have come off the printer without any modification. Okay, so we now have a GT2 belt inserted into this component here. Awesome. Let's do the same for the other side, because we actually need 3 of these, but because we're not assembling the X gantry, then we do not require to play with that at all. Right, okay. So let's get the nut. Let's put the nut in place. Hey, hey, hey! Welcome in. How you doing? We're building a LuminPnP. It's a pick and place machine. It inserts electronics components onto a circuit board, and it's an open source hardware project from a company called Opulo, and we're having some fun putting this together. It's snowing in Nova Scotia. Huh. Okay, that's not catching a thread. Why is that not catching a thread? Have I got some stuffs? Holding that up. There we go. The socket wasn't just fitting in to the hole. The tolerance is very tight here. Just backing that out. Okay. So this is the first time I've made anything like this machine. I have made a 3D printer before now. And we're reusing some of Frank's parts to make this machine. Super cool, right? Okay, so that's in there with the locking nut. Okay, so we've got that complete. The next thing is to get it inserted into the front left and front right legs, but we've only got one leg to do working on right now. There's got to be some M3 hardware put in here to actually do the tightening. So we want the nut to be facing this little insert here. You're contractually obligated to say the original Scotia is better. Right, Dimitri? Okay, so let's quickly take a look at our design. And if we select the bolt, it tells us that we want an M540 screw. So let's find my pack of M5x40s. Okay, let me just slide that in place. And again, it's going to be a lock nut. I'm hoping I read the bill of materials right and ordered enough of these things. I'm looking at them thinking, have I got enough? I don't know. Right, okay, let's see if I can get this locking nut in there. And this is where old man eyes really start to play me up. What was that? 7 foot deep. Oh, wow. You got a snowdrift of 7 feet deep in Nova Scotia. That's crazy. Well, stay warm. That's the most important thing, right? Okay, so we've got the nylon. We got the nylon inserted nut in its position. We now need to get this pin in, and then we need to tighten it up. Awesome. Okay, so that's one leg done. Now, I did say we're going to be using some of Frank's parts, and in a moment, we're going to be digging out Frank's motors, and we're going to be putting them in place. I think I'm done with the M5x25s for a second. Let's get this other unit in place. So if you guys are not already subscribed to the channel, please hit that subscribe button. It really helps. We're trying to grow the channel as much as possible. We're trying to get that monetization badge. And any support, no matter how small, is absolutely appreciated. Alrighty. So that's the two front legs mostly assembled. I'm going to set this one aside. And what we're going to do now is we're going to delve into... attaching a NEMA 17 motor. So this is a NEMA 17 motor from Frank. Frank was of Rostock. So we had 3 vertical axes, and each of these motors, they controlled one of those axes, and then we had one for the extruder. So we've got a total of 4 NEMA 17s, which is perfect because we need 4 for this project. I'm going to use Frank's pulley as well. So we're going to take that off for a moment. And we'll set that aside to go somewhere safe. Right now, I need to break out a box of hardware. And we're actually going to be using Frank's screws as well. So this is... these the longest I've got. This may be where we hit a bit of a blocker, but we'll see. I'm hoping these M3 screws are going to be long enough to install Frank. Oh, no problem, because they actually, I don't need anything anywhere near that long. Right. In fact, what does the CAD drawing say we need? That's probably the smart thing to do, is to check the CAD drawing. Now, where did that go? Oh, did we just crash? Okay, FreeCAD just died on me, so we're going to have to load that back up. Don't you just hate it when that happens? Oh, no. We got it. Okay. What are we looking at? There's bolts in there. What are you? You are an M3x8. All right, I need to find an 8mm M3. So let me grab my calipers, because unfortunately my M3 hardware is not labeled. I'm just going to be over here a moment. That's going to be way bigger than 8mm. What do we got here? That's somewhere in the 20 range, right? Yeah, that's 23mm. Okay, maybe this. Okay, let's see what that looks like when we drop that in place. That may actually be good to go. This is exciting. This is exciting. Okay. They are slightly too long. I need the next size down in my box. I'm hoping I have some which are slightly smaller. Okay, so it's not you. You need smaller ones. These smaller or bigger? They're bigger. It's not them I need. Just checking my itinerary here. I'm hoping that we're going to have hardware to fit these. Otherwise, that's an order which I don't particularly want to make. Oh, you beaut. This'll work. This is going to work. Oh, yes. So I will need to make my own harness. Will need to make my own harness. One way or another, we're going to make this hardware work. Even if I have to grind down a couple of the other screws to get them to the right length, I'll do that. Just so I can say I used Frank's hardware to get this LuminPnP to put together. So we are taking the approach, kind of the approach of if you build it, they will come. For those of you who don't know, that's a Field of Dreams reference. So I'm bringing the wires out this side so I can kind of route them either internally or externally. I think we're gonna go, yeah, we're gonna go this way. So this will be the right leg. So that is a right rear leg assembled. Okay, let's do the other rear leg so that we've got a matching pair, and we can say that all the motors are mounted. So this motor is the old extruder. So I'm not quite sure where I'm going to use this one. I think symbolically I might put this on the head that has the vacuum pumps. So we won't use that in this instance. So let's grab another. Okay, let's remove the GT2 pulley. Okay, so we got a second motor. So where this exited on the left, we're going to get the other one to exit on the right. So, whoop. So we want that like that. Awesome. Haha. So does anybody in chat already have a LuminPnP? And if so, can you provide any sort of feedback on how you found it? Everything that I've seen about this machine is really positive, so I wouldn't be investing the time and effort to build the machine if I didn't think it was any good. Okay, so that's the corners. I always like to tighten the corners, opposing corners, just to relieve stress. So you're not, you know, probably doesn't matter that much because it's not like a car. You're rebuilding an engine or something, but I don't know, habit. So yeah, we'll be making our own wiring loom for this, so I'm not worried about these wires being short or anything like that, because we're going to have to fix that anyway. Okay, so I've now got wires facing inwards. That'll be good to capture the wires onto the rails. Okay. So that's all of the M3 hardware I want to use right now. I will need to use some more in the future, but I'm not gonna worry about that. I need to keep this moving forward. So this is where we start to introduce some T-slots. Let's put our screws away. That's probably a good thing to do. To keep ourselves neat and tidy. And I am missing a bunch of boxes. Where? Oh, there they are. Like, duh. Okay, so we can go there. And I'm missing one more. One more box, please. There you are. All right, so let's put that back. Let's put that back away in my organizer. Okay, so now we're breaking out the T-nuts. So we got a bunch of T-nuts. I need to have a look to see how these T-nuts actually go together, because I am not entirely sure. So we want one of those. And what do we want? This is M5 hardware. So let's have a look at what we need. So this is an M5 by 10. Are they all M5 by 10s? Yes, M5 by 10. All right. So I'm just going to check some documentation to see which way the T-nuts go. Like I say, there's an assembly guide. I'm just going to quickly pull up the assembly guide. Okay, that's unboxing. In fact, let me show you this, because this is actually pretty cool. Right, so this is the experience that an Opulo customer will get should they buy this machine from Opulo, right? So let's go here. So you get this online assembly, right? So it goes into, you know, unboxing it, assembling the frame. That's where we want to go. So you see these components come fully assembled, right? Which we don't have. So let's have a look at, okay, so you got your T-nuts. Correct, incorrect. Right, okay, so that should be... Okay, I got it. I understand. So what we got to do on here is have the T-nut installed. Like that. But then it needs to be orientated so that the extrusion can slide into it. So I'm going to do the front extrusion because that to me looks the easiest. Let's do the bottom one first. So let's put in that like that. And this is where I find my dexterity is not the greatest. But we persevere. Okay, so that's one. Right, Dimitri? That is some deep snow.